Hello, Mustangs. This is Mr. Greenwood. I'm glad to be back with you all. Hope you had a wonderful spring break and you're all safe and healthy. Well, to jump back in, what we want to talk about in this first section of the new unit, Unit 6, is three forms of a quadratic. Okay? But before we jump into that, what I want to do is go through just a little bit of a review of what we already know about quadratic functions. And we've talked about the vertex form of a quadratic. Okay, so a couple of things on this slide that we see are shape and concavity. Okay, so we know that the shape of a quadratic function forms a parabola. Okay, that's its basic shape. And then for concavity, we have two different options for concavity. It can be concave up or it can be concave down. Concave up meaning that the parabola opens upward, or concave down meaning that it opens downward. Okay. What else do we know about quadratic functions? Okay, well, we know that there's a y-intercept, and every single quadratic function will have only one y-intercept. Okay. We also know that there are three possibilities for x-intercepts. Okay, a quadratic function can have 0, 1, or two x-intercepts. Okay? And as you can see from that first drawing or graph, this one does not touch the x-axis at all, so it has 0 x-intercepts. The second one touches the x-axis at exactly 1 point, so it has 1 x-intercept. And then the last one touches the x-axis at 2 points, so it has 2 x-intercepts. We also talked about the equation of a quadratic function in vertex form, and as we recall, it goes y equals a times the quantity x minus h to the second power plus k. Okay, and we found out before that the h and the k create the vertex. The h and the k is where h is the x coordinate and k is the y coordinate of the vertex. And as you can see over here, the vertex for this particular function is at 1, negative 1. Okay, so in this case, then, our h value is the 1, and our k value is negative 1. There's also the a value. We've not talked about that in a little while, so we want to go back over that one. The a value determines both the concavity and the width of the parabola. Okay, so if you recall, if a for concavity, if a is positive, the parabola is going to be concave up. But if a is negative, the parabola is going to be concave down. And so that's going to be determinant for concavity, whether a is positive or negative. Now, as far as the width, our a value is going to determine how wide or how narrow the parabola will be. Okay, and the larger the absolute value of a is, the narrower the parabola will be. So here's a couple of examples here. Okay, so this one, our a value is 1 in this particular parabola. Okay. For the second one, our a value is 2, and as you can see, this parabola is narrower than the first one. And then for the next one, our a value is 3. That means that this one will be even more narrower. Okay. And when I say the absolute value of a, I say that because we could have a negative value for a. Okay, but we want to look at the absolute value of it. Okay, so in this case, all three of these are concave down, so our a value is negative. Okay, but our a value is a negative 1 here. So we have this curve. But the absolute value here is 2. So 2 is greater than 1. So that means this one is going to be narrower. And in the third one, our absolute value here is going to be 3. Okay, which will make it even more narrow. Okay, so the a value determines concavity as well as width. Hope you all are recalling this. All right. Let's talk about our next thing. And this is new for many of us. Okay, so like linear functions, quadratics have three different forms. Okay, the first one, vertex form, we know. Okay, y equals a times x minus h to the second power plus k. And this is an example. We could have y equals 2 times x minus 1 to the second power plus 3. Okay, the 2 is our a value, the 1 is our h value, and then the 3 would be our k value. Well, we can also have standard form, okay, and it's written like this: y equals a times x to the second power plus b times x plus c, okay, where our a, our b, and our c are just numbers, okay? And anytime we have a number in front of a variable like this, remember we call those coefficients. So a would be the coefficient of the x squared term, b would be the coefficient of the x term. Okay, so here would be an example of a standard form quadratic equation. Y equals x squared plus 2x plus 1. Okay, so our a value in this case would be the coefficient right in front of the x squared, and since there's nothing there, that's like having a 1. Okay, so our a would be a 1 in this case. For this one, the b would be the 2 represented by this coefficient right here, and then our c value would be a 1. Okay, so that's standard form of a quadratic. And then finally, we have what's called factored form, okay, where we have y equals a times x minus some number times the quantity of x minus some number. Okay, so this might be an example here. Okay, y equals 3 times the quantity x minus 4 times the quantity x minus 2. Okay, so we have 4 as a number, and we have 2 as a number in factored form. Okay, and these are specific to our graph, which we'll find out what those actually mean in just a moment. Okay, so here we have a quadratic function, okay, represented by a graph and represented by a table with its coordinate pairs. Okay. So the three forms of a quadratic that we're looking at here, we have the vertex form, where we have y equals x minus 1 to the second power minus 4. Okay. We also have standard form, y equals x squared minus 2x minus 3. And then we also have factored form, y equals x minus 3 times x plus 1. Now, coincidentally, each of these three equations represent this same function. Okay, each of these, vertex, standard, and factored form, are all represented by the same graph and by the same table. Okay. So one way that we can determine and check to make sure that each of these functions represents the exact same graph is to plug in the same coordinate pair into each of the equations. Okay, so let's try that first. Okay, we're going to just pick a coordinate pair, and let's say we'll just pick this one, 0, -3. Okay. So if we were to plug in a 0 for our x and a -3 for our y in vertex form, okay, so we plugged in a -3 equals 0 minus 1 to the second power minus 4. Okay, well, we can check and see if that is true or not. Does the left side equal the right side? Okay, so -1 minus 1 is, or I'm sorry, 0 minus 1 is -1, and then you square it. So -1 times -1 is a +1. And then a +1 minus 4 gives us a -3. So we have -3 on the left equals -3 on the right. Okay, so that ordered pair is definitely on our parabola. Let's check that same coordinate pair, 0, -3, in standard form, and then again in factored form. Okay, so we're going to plug in a -3 for the y, and we're going to plug in a 0 for our x's. So we're going to have 0 squared minus 2 times 0, and then minus 3. Well, 0 to the second power is just 0, and then minus 2 times 0. Well, 2 times 0 is also 0. So 0 minus 0 is still 0, and then minus 3. Okay? So on the left, we still have negative 3, and on the right, we have negative 3. So we've checked out there also. Okay? Let's check one more time with factored form. Okay? We're going to plug in a 0 for the y, negative 3 for the y, and 0 for our x. We're going to have 0 minus 3 times 0 plus 1. Okay, so on the right-hand side, 0 minus 3 is negative 3. This value is negative 3. And 0 plus 1 is 1. So we're going to multiply here. Negative 3 times 1 gives us a negative 3. Okay, so on the left-hand side, we have negative 3. On the right-hand side, we have negative 3. So that means that this point is on every single form of this parabola. Okay? And coincidentally, no matter which of these ordered pairs we plug in, they will all check out for the vertex form, for standard form, and for factored form. Okay. Okay. Now there's some important information that we can get from each of the three forms for quadratic. Okay. So I have the very same parabola again and table. And we have the vertex form, standard form, and factored form. Well, obviously from vertex form, okay, it's given away by its name, we can determine what the vertex is. Okay? And we've seen that in the past. We saw that this is our h value, and this is our k value. Okay, so our vertex is 1, negative 4 in this case. Well, standard form gives us the y-intercept. Okay, and our y-intercept, we know that the y-intercept is going to be gotten by plugging in a 0 for the x. Okay, so if we plug in a 0 for the x, okay, 0 squared minus 2 times 0, and then minus 3. So then our y value is going to be negative 3, and that's our y-intercept. So in this instance, this gives us a y-intercept of 0, comma, negative 3. Okay. Our factored form, on the other hand, gives us the x-intercepts. Okay, and the x-intercepts, we know we can get the x-intercepts by plugging in a 0 for the y. Okay, so if you look down here, we have a 0 for the y value, 0 for the y value, and in this instance, we will have 2 x-intercepts. Okay, we have 3, and we're going to have a negative 1. Okay, so x-intercepts in this instance, 3 comma 0, and negative 1 comma 0. Now you want to make sure to pay attention to your signs. Okay, our function tells us that y is equal to x minus some number times x minus some number. Okay. Well, if we're subtracting but getting a positive 1, that means that we would have to subtract a negative to get that positive. That's why we're getting this negative 1 right here. Okay, so minus a minus 1. Alrighty, so those are 3 things that we can gain from the different forms of a quadratic. We can find the vertex if it's in vertex form. We can quickly find the y-intercept if it's in standard form, or we can quickly find the x-intercepts if it's in factored form. So let's do a quick practice run. What information can we get from each of these functions? Well, first of all, looking at this function, okay, what form is it in? Okay, well, it's in vertex form. We've seen that plenty of times in the past. So let's take a look. Okay, if our function is y equals a times x minus h to the second power plus k, That means then that our h is going to be 1, our k is going to be 4, therefore our vertex is going to be the coordinate pair 1, 4. Alrighty. Okay, going on to the next one. The next one's in standard form. Okay, looking at this one. So we have our a value. Okay, our a value in this case is 3. Our b value is 2. And our c value is going to be a -6. Okay, -6. Because our function is y equals ax squared plus bx plus c. Okay? So our c value in this case is a -6. That means that our y-intercept is going to be -6. Okay? Okay? But we don't want to just write -6. We also want to use a coordinate pair. So the y-intercept we would write as 0, -6. Okay? All right, and then the last one. This is in factored form. Factored form is going to generate for us the x-intercepts. Okay? And our function is y equals x minus some number times the quantity x minus some number. And of course, we have our a value out front. Oops. Let's undo a little bit of that. Okay. Still getting used to my new pen. Okay, here we go. Okay, so in this instance, okay, we have x minus some number. Well, in our function, we have x minus 2, so that some number must be 2. Okay? Times x minus some number. Well, this is a positive 1 here, though. So that means that we're going to have x minus a -1. Okay, so this some number right here has to be a -1. All right, so those are x-intercepts 2 and -1. But of course, we want to make sure that we write those as an ordered pair. So we'd have 2, 0. We'd also have -1, 0. All right. Now here's what I would like you to do next. I want you to go ahead and pause the video, and I want you to go to desmos.com and type in each of these functions onto the same graph. Okay, and you should, or actually not on the same graph, just put them in separately. Okay, and see if you can determine that for sure our vertex is 1, 4. And then for sure, for the next one in standard form, that our y-intercept is at 0, -6. And then for the third one that you're going to type in factored form, we want to make sure that when we visualize it, our graph has x-intercepts at 2, 0, and -1, 0. Alrighty, I hope this was clear, and if you do have additional questions, we will have some more practice with this in the next couple of days, and we will be posting more resources as they become available, and we will share them with you. Have a good day, Mustangs.